Thanks for joining me in today's lesson. In this first tutorial, we will find inverses using an algebraic technique. So we're back into section 6.4. We've actually already been here. We talked about inverses graphically earlier this year. Today we're going to be talking about inverses algebraically. So let's remind ourselves a little bit about inverse functions. Inverse functions will undo each other. We learned earlier this year that we could just swap the domain and the range to get from our original function to our inverse function. For example, if we have a quick little table of values, just three ordered pairs here of an original function, to get the inverse function, all we need to do is swap the x's and the y's. So the 3 and the 4 will change places. So it'll be 4 and 3. And the -2 and the 6 will change places, 6 and -2. And the 1 and the 7 will trade places, 7 and 1. That's the simplest way to find an inverse. Just swap the x's and the y's. Let's say we're looking for an original function and we have what its inverse is, or at least a couple of ordered pairs, a few ordered pairs. Same thing. All we have to do is switch back and we'll have the function. So instead of 1, 2, 3 being in the domain, we will have 1, 2, 3 be in the range. And then the range of our inverse function, which is 2, 4, and 6 here, will become the domain 2, 4, and 6 of our original function. So we're just swapping domains and ranges. And that will help us to understand why this algebraic technique will work. It's a simple four-step process, and here are the steps to finding the inverse using our algebraic technique. And I'm going to follow those 4 steps with our first example. So here's our first example. F of x equals x plus 4. A pretty simple function to deal with at first. Our first step is, let's change our f of x, which is really just a fancy name for y. Let's change it back to y. So f of x will become y. Then we know where our domain is, which is our x, and where our range is, which is our y. Step 2, swap the x and the y. That will take the domain and the range and it will swap them. So instead of y equals x plus 4, we're going to have x equals y plus 4. We literally change the x to a y and the y to an x. Next, solve for the new y. Our y is now over here. All we have to do is solve the equation for y. So we have to get rid of this 4, so we'll subtract 4. If you don't mind, I'm going to start with the y. I'm going to have y equals, and I'll put this x minus 4 over here. So we have y equals x minus 4. Not too bad to solve for the y. Our final step, since we started with the fancy symbol f of x, we're going to end with our fancy symbol f inverse of x. This is our symbol. Remember, it's got a little -1 sort of up in the superscript area. F inverse of x will be the name for our inverse function. So instead of y, f inverse of x. And we found the inverse. Our original function was f of x equals x plus 4. Our inverse function, where we use this special symbol, is x minus 4. And that makes sense because these are inverses. They undo each other. If you have a number and you add 4 to it, and then you take that result and then subtract 4, you're back to the original. So let's see if we can follow those 4 steps for example 2. Example 2 is a of x equals 2x minus 1. Our first step, let's change our fancy symbol to a y. So a of x is going to turn into a y. And now I have y equals 2x minus 1. Our second step, let's switch the x and the y. So y becomes x, and now I have x equals 2y minus 1. Our third step, let's solve for our new y. Here's our y. I need to divide this coefficient of 2 away, and I need to add this subtraction of 1 away. And I'll do that in reverse order. Let's add 1 to both sides. X and 1 are not like terms, so I'm not going to put them right underneath each other. I'll draw my line and cross that out. 2y will be all by itself. And on this side, since they're not like terms, x plus 1, I'll just write side by side as x plus 1. Now I need to divide the 2 away, so I'll divide this side by 2, and I'll divide this entire side by 2.
And now I have y equals, y is all by itself, x plus 1 all divided by 2. Now, this is a fine answer for our inverse, I suppose, but sometimes we want to be graphing our inverses, and if we keep it all as one big fraction, it might not be the easiest thing to graph. So one thing I might do is separate this single fraction into two individual fractions, x divided by 2 and 1 divided by 2. That's maybe a little bit easier to graph, and actually a little bit better yet, instead of x divided by 2, let's write it as 1/2 times x plus 1/2, because there is, of course, this 1 right here, and it might be easier for us to see the slope. So all three of these versions are absolutely fine answers for our inverse, but understand this last one might be the best version if we are intending to graph it, because now we can see the slope is 1/2, and the y-intercept actually is also 1/2. But let's not forget our step 4. Step 4 says to rename our y as our fancy inverse symbol. Since I started with a of x, our inverse symbol will be a inverse of x. And I'll just say that it's equal to, I'll circle all three of these versions of the answer. All of them are fine, but remember this one is probably the best if we want to graph it.
Okay, let's look at example 3. Here's g of x. 1/3 x plus 2. First, let's change it to a y. Y equals 1/3 x plus 2. Next step, switch the x and the y. So the y is going to be x, and the x is going to be y. Step 3, solve for this new y. I need to get rid of the 1/3. I also need to get rid of the 2. I'm going to get rid of the 2 first. I'll subtract 2. I'm going to write the 1/3 y equals, over here I had x minus 2. Instead of putting it over here, I'm just going to put it over here. It's okay. It's just the symmetric property, x minus 2. To get rid of the 1/3, I'm going to multiply all parts by 3. So I'm going to multiply this term by 3. I'm going to multiply this term by 3. And I'm going to multiply this term by 3. 3 times 1/3 cancels away, and I'll have y all by itself. 3 times x, of course, is 3x. 3 times negative 2, of course, is negative 6. Don't stop there. We started with the fancy g of x, so we're going to end with a fancy g inverse of x. And there we go. This symbol, if you wanted to take a quick note, the way to read this is either f inverse or the inverse of f of x. I like to say f inverse or g inverse or a inverse. And let's do our final one. We've got h of x now. Okay, change it to a y. It's just easier to deal with a y rather than the symbol f of h of x. Take the x and the y and swap them. So the y becomes x and the x becomes y. The squared is still there, the plus sign is still there, the 3 is still there. We just changed x to be a y. That did not do anything to the exponent. And then step 3, solve for this y. Well, I am going to need to get rid of this squared. But before I do that, let's get rid of the 3. I've got to do that one first. Subtract 3. Whoosh. I'm going to write the y squared first, just because I like that to be on the left side. X minus 3, again, they're not like terms. Notice that I'm not putting them right underneath each other. I'm putting them off to the side because they're not like terms. I have to write them side by side. X minus 3. Now I need to get rid of the squared. To undo that, I'm going to take the square root. I'm going to take the square root of both sides. Now remember, when you put a square root or actually an even root symbol on either, in your equation, you have to remember plus or minus. That's just one of the things that has to happen when you put a square root or an even root symbol in your equation. The square of a square root, the square root of a square, cancels out and we just get y. And then the square root of x minus 3 is just the square root of x minus 3, but we put the plus or minus. And then last step, of course, it was h of x, and now it's h inverse of x, since we followed all 4 steps. Plus or minus the square root of x minus 3. So that's how you find the inverse algebraically given any equation. Thanks for watching this tutorial. I'll see you in the next one, and we'll practice this next class. Thank you. See ya.